All right, good morning, everyone. So if you know, you know. MongoDB Atlas Search enables you to easily build fast, relevant, full-text search on top of your MongoDB applications. In this session, Marcus will take you on a journey of what Atlas Search is, why we built it, and highlight some use cases where it really shines. You will get an insider view of what's next on the Atlas Search product roadmap. Marcus Egan is a staff product manager at MongoDB. His role is to understand the challenges and impediments of building rich search experiences in your applications, and his goal is to make it easier to have a conversation with your data. Please welcome Marcus to the stage.
Good morning, everybody. Could you all do me a favor? Can you hear me? All right. Could everyone here set an alarm on their phone for 11 minutes from now? Yeah, 11 minutes. And if it's not set in 15 seconds, I'll say don't worry about it. But as many of you as possible, 10 seconds left, and 11 minutes, we want alarms. No more need to add alarms if it's not added already, but if you have an alarm, perfect. I'm going to talk to you today about why we built Atlas Search and where it's headed. And I'm also joined in absentia, but in spirit, by my colleague, Matt Keep, who is in the UK and not feeling well. So he'll be feeling better, and I'm grateful that he stayed home because he's not feeling well. But he contributed a lot to this vision talk as well. All right. So here's a safe harbor statement, forward-looking statements here. But let's talk about how application search is built today. There's a few ways. You often see this search box and you understand that it can drive the most meaningful interactions with your customers. Really, they're talking to you in natural language. But the way people do this naively in a database is they'll use like contains, like, a regular expression, or in MongoDB, there's often $text, which I wouldn't recommend to a dead cat. And don't get confused by when we talk about $search, because there is a $search and $text, but that's a different one. This is a legacy system that we don't work on. It doesn't really have the rich features or the relevance tuning options that a search engine has. And the worst part about it is that it impacts your OLTP workload. The transactional workload that you stood the database up for is reduced, or its efficiency is reduced, its capabilities, and people go to the second option, which is you add a bolt-on search engine. And so right now it seems easy. It's like you have your operational data store. I'm going to keep it separate from all this search nonsense and set up this persistence layer. But then you add the search engine, and it's another system. So now you have your document data store, and you have your document search engine. We're still talking about collections here and documents with two separate clusters. And the reason people go to this solution is Apache Lucene, which is powering Elasticsearch and Solr. You get fuzzy matching, autocomplete, a lot of language analysis capabilities. But then there's another component that people often don't think about when they bolt on this search engine. It's the sync pipeline, the sync infrastructure, ensuring that updates are available and all the data in your OLTP gets to the search engine. What does that lead to? Just more cognitive load, right? You have different APIs for similar queries. You have to pay the sync tax, which is like the actual infrastructure for the sync pipeline, but also the context switching, right? And there's more operational overhead because you have to provision, scale, upgrade, patch these two new systems, and all the associated dependencies, right? The drivers. And for those of you in the audience that are dealing with a bolt-on search engine and drivers, you probably know what I'm talking about. It's a pain. 3 separate systems. This slide speaks for itself. It has to be a better way, right? And Atlas Search is all about simplification. We eliminate the need to have this sync pipeline. We can simplify the architecture. You're just sending your data to one place, one cluster, and you get security and updates out of the box because the platform is managed. You don't have to worry about the sync or the dependency management or any of the other overhead. Remember that cognitive load is so important. When we compress these 3 systems into one, all the things that you want for your operational data store and all the features that you want for your search engine are in a single system. Customers say they ship features 30 to 50% faster. We've had a couple customers recently just publish case studies on our website, one as recently as today, where it's even 90% faster because they don't have these disparate systems to worry about. The use cases that we're focused on are very important because we're not saying we solve all problems. We're a drop-in replacement for everything that Solr and Elasticsearch does. That'd be silly. We don't have Cabanas, right? So we don't have Beats, all the observability features in those systems. Target use cases we're focused on is application use cases. Catalog and content search is a very common one that comes to mind. And you can think about it as the search box on Amazon.com or the left-hand nav on Amazon.com, but it's also the personalization service where the search index is enabling you to query in different ways, query the database in different ways. You can have hundreds of fields in your search index, for instance. And also in-app search and single view, where you want to give your users a natural language interface to surface data and a lot of documents without necessarily knowing where it's coming from or what they're looking for. And this is an area where autocomplete and fuzzy matching are very important because maybe you don't know how to spell their name, maybe you don't know what their name is all the way, and we can just sort of guide you along that journey. Who's using Atlas Search? You might be surprised. I get this question a lot, like, how new is Atlas Search? We can't put something new in our stack. Well, it's based on Lucene. Lucene's not new at all. It's very mature. Just a snapshot of some of the people using us. One of the world's largest grocery retailers, a top 5. One of the world's largest real estate agents. They spoke here yesterday. It's a very large company. Many of the largest stock exchanges, not just one. Professional social networks, one that probably many of you use. Sports car manufacturers, one of the largest insurers, grocery delivery services, home fitness, and online music learning. So these use cases are very legitimate use cases for search engines, but they're not what we're focused on. Log analysis, SIM tools, observability. These are things that you could accomplish with Atlas Search, and we have some users using it, but it's not our focus, and I just want to be clear about that. Enterprise search is, lots of connectors, all kinds of things, not what we're focused on. Now, I will show you briefly Atlas Search in action, so you can get a sense of what that single view, what the single view capabilities could be like. And then I'll jump back to the rest of the deck. So here you can see I have an index. This index is on the sample influx comments collection. So it's from the sample data set. Everyone here has access to it. Where in this collection, there is a field called email where there's diacritics in some of the names. There's the @ symbol. There's a dot and a domain. And too often we see customers trying to achieve this type of search, and they struggle. And in just a minute, I'll get the warning that I asked you all for, I think. So this is an analyzer field where you can drop in a custom analyzer. Basically, I'm taking in the email URL extractor, and I'm applying that field as an analyzer and a search analyzer to parse my input and parse the documents in the collection. Let's take a look at what it looks like to query this. So the index name is default, so I don't need anything. And just like that, before I'm even done typing, look at that. That's how easy it is to get set up with Atlas Search. I introduced the feature to you and wrote an autocomplete query and surfaced the results just before. I mean, that was almost perfect timing. And so now people can sort of see how you get a glimpse at like the type of capabilities you can get and exploit from this feature. So if we were to maybe, I think it's like Game of Thrones characters in the collection. So maybe if I try Robert, I might get like the Mad King. I'm not sure. Let's see. So there's Mercedes. Let's see, John, there's a John. So it's pretty straightforward. So that's autocomplete on emails and our custom analyzers functionality. Let's go back to the deck. Uh-oh. I lost my place, I guess. So let's talk about the future product direction. I think that's why a lot of people are here. Some people probably already know about some of the features we have. Our priorities have never changed. They've always been about giving users the tools to fine-tune the search results through a variety of operators, options, analyzers, and features. Above that is developer productivity. We want our customers to be able to move faster than the competition, right? And every disparate system, every different driver, every different API is adding cognitive load and context switching that can be costly in a very competitive space. You can launch and iterate much faster with Atlas Search. But we're also focused on speed, scale, and resilience to power the world's mission-critical workloads, some of the largest query volumes and most complex use cases out there. But we're sort of limited today. Without going too deep into linear algebra, you can think of how Lucene organizes data as really sparse vector-based search, right? Where on the y-axis, on the y-axis, we have a field that is juicy, like how juicy a fruit is. Let's call it a fruit. And then on the x-axis here, we have another field called sweet. And how sweet is a fruit? So maybe bananas are super sweet, but they don't have any juice at all. So they're down here. I've never ate a prune, but I'm guessing they're pretty dry. So, and not that, they're pretty juicy before they get dried and not that sweet. So, and so you can see there's limitations and how we do search today where it's like a term plus a boost, or field plus a boost, or a field and a term plus a boost and a field, term, boost, like it never ending. And there's some things, some guidance, some tips we can give you to master this or improve upon it. But where we're taking this is an era that's not about text matching, where we're not even thinking about the fields, where we're thinking about the context, the proximity in the language itself, right? So we're releasing dense vector-based search in Lucene. We'll be the first vendor to offer Lucene-based dense vector search to the world. And the reason why that's so important is because we're next to the database. So we have this durable data store where people haven't thought really about vectors being something you need to worry about in a transactional use case or an OLTP workload. And we want to make it much easier to search based on text, maybe images in the future, and even sound. If you vectorize this data and we calculate the Euclidean distance between an input and a collection full of vectors. And that would be in 6.0. It's not released to the world yet, but 6.0 is available as a release candidate. So I encourage everyone here to set up a cluster in Atlas using the release candidate, I think RC7 or RC8, 6.0, because this is where dense vectors will come. And by the time you're ready with your collections vectorized, it'll be available. The path that we're on is a path that we've been on. It's a multi-year path, but we've been working to further democratize sophisticated work. In the same way that we democratize building an application with the document data store and BSON, which looks like the JSON you work with in your programming language, which looks like the data that comes out of APIs, that continuity, we're trying to bring that productivity to data scientists, people working with PyMongo Arrow, which we released last November, to work with data frames and Jupyter notebooks and feature engineering and hyperparameter optimization so that you can test and validate this new era of search, where sneakers match shoes, but there's no synonym entry for either, right? That's what we're trying to bring to the world. If you are interested in dense vector search in our early access program, you can send me an email. My email is here. And the only payment for our early access program is feedback to Vonda and I. So Vonda's here. You can actually sign up with her. She's in the crowd. And we want to work with you closely to understand how you're using the features, what challenges you're having. And I promise some of the things that we're unveiling are going to make it easier than ever before to build Google-like search into your applications. Sessions you can't afford to miss today at 1:30 to 2. There's creating engaging experiences with Atlas Search, which I'll be speaking at that one as well, and with my colleague Elle Schwer. And then tomorrow there's a workshop, Score Big with Atlas Search, that'll just help you take that first step or level up your skills if you've already done so. And that's in 405.1. Sign up for Atlas Search in the free tier. Please go through the documentation and give us feedback about it. And if you need any advanced assistance or training, there are a lot of options within MongoDB. So yeah, I want to leave time for questions.
Thank you, Marcus. Did we have any questions? No questions? Okay.
This may be a specific question, but do you see the Atlas search being like compatible or available for like geospatial data as well?
It's already available for geospatial data today, so you can index data as a geotype, and then you have geo within, which you can draw a box, a polygon on a map, and search within those boundaries. There's also a consideration where MongoDB has geospatial search and Atlas Search is geospatial search, but MongoDB is a curved earth, and Lucene, lat long query parser, is point to point. It's a flat earth. So Atlas Search is really good for small distances and text-based criteria, and MongoDB could be the right solution if you're looking at a flight path, for instance. So you're welcome.
Thank you. Any other questions? Saw a hand in this area.
When is search coming to serverless? Any timeline?
Yes, it's a good question. The work is not currently scheduled exactly. There's a number of dependencies in how serverless is architected and how Atlas Search is architected. We will have a couple different deployment options around next summer, or it could next summer, next fall, roughly. But specifically on Atlas serverless, that's a ways out.
So we have seen while we're using aggregate for multiple collections, there are performance issues. So how you addressing that problem with the search? I was trying to look into search in joining multiple collections and doing search on that.
So in the talk later today, I'll actually be discussing union with and lookup, which we just released in 6.0, so you can try them in Atlas today. And in the demo, I'll be showing some queries for union with and lookup. Union with is more like cross-collection search. Lookup is going to be more like a join. But we have those capabilities, and they will be here forever, constantly get better. So we just released them on Tuesday, is the answer to your question. But there's another person back there.
Was there another question?
If we use field level encryption, how can we even use Atlas Search against that data?
Yeah, so it's a great question. So field level encryption specifically, like on the field that you encrypted, you can't search that field. And that's like not a MongoDB problem, that's a physics problem. So like one day we'll get there, and trust me, the Oroki guys are working on this. It'll be a long time. I don't know how long, but we are today, what you can do is if you have encrypted data in a collection, that field can be encrypted. You can search non-encrypted data, and then in a subsequent stage in the aggregation pipeline, maybe a match or another stage you can use. As long as you project that field, the encrypted field, you project that field, you can use that field in a subsequent stage in the aggregation pipeline. But it won't be a search operation.
Yeah, in addition to the same question, field level encryption, it's not possible. Can we use it if it's a native encryption, like complete encryption of data?
Yeah.
Or yesterday you guys introduced client-side level encryption.
So the queryable encryption, like you can query with MongoDB. The challenge, I think, the challenge with encrypting search indexes, like a lot of people want it. Our volumes are encrypted, so every Atlas volume is encrypted. So the data is encrypted at rest. The challenge is that when you send text data through an analysis chain, in Lucene, it becomes fundamentally different. And then there's a lot of other metadata about that data. Maybe it's pre-computed statistics. There's a postings list. I mean, there's an engineer from at the Atlas Search team in the audience. He can tell you all about it. It would be very difficult today, based on the state of the art and the state of the Lucene codec, to introduce encrypted search, like the ability to search those fields. Usually what people want is to encrypt some fields in the document and search on a different field. Now you can queryable encryption, you can do prefix matching and exact matching with what we released yesterday, what we announced in the keynote. But that's not Atlas Search.
And another question is, what is the degree of search we can go with this one?
So the degree of search, I'm not sure what you mean. I mean, we have customers with billions of documents. Is that what you mean?
How many letters can be mismatched for accurate search?
So this is a good question. So there's a few ways we solve this. So in Lucene, we can only rewrite queries that are a Domrall-Levenstein edit distance of 2 or 1. And this is just like the limits of the algorithm today. And if you're familiar with that algorithm, that gets a lot of the cases, but that still doesn't get all the cases. The way we tell our users to handle beyond 2 is synonyms, right? So PIDA, you really meant iPad, but you're on the tiny buttons. You can add PIDA, iPad as an equivalent synonym in your synonyms collection. What's great about synonyms in Atlas Search is we don't require a re-index. It's just a MongoDB collection in the same database as your search collection, and it's available as soon as you add it. So we have customers who take zero result queries, which are probably grave misspellings, and rewrite those queries as synonyms to match a document or a term that does exist in the corpus. I hope that answers your question.
Any other questions?
Hey, Marcus. With respect to the resource, how is Lucene, using the resource? Because we have our collections and we have like the tiers M30, M40. Within that, Lucene, how much of the resource that it uses in, let's say, in percentage? The second question would be the index. It has dynamic indexing or dynamic field index, whatever it's called. So is that going to take a lot of space, because now you're putting a search index on the whole collection, which means it can add up more indexes behind the scene, right?
Yeah, so that's a great question. So a dynamic index is often bigger than an index where you specify the fields individually. There's an exception. If you have a lot of autocomplete fields, but not a dynamic index, those can sometimes still get very big if you have a wide min-gram, max-gram width. Now, on the resource utilization, it's an interesting question because it depends on what you're doing with your MongoDB cluster today. Like, we have some customers who are running hundreds of millions of text queries or case-insensitive regular expression queries, where Atlas Search might actually help them reduce the consumption, resource consumption. Other customers that are doing everything right in MongoDB and piping their data to another system just for the purposes of search, they may have to tier up their clusters because they've consolidated workloads to one cluster. We don't see too much resource contention. We use roughly 40-ish% of the available resources, whatever we need from a storage perspective, but as far as like RAM, CPU, we use around 40-ish%. We also are sharing with the Wired Tiger Cache and MongoDB. So.
Hey, Marcus. I had a question about, it'd be handy to have either kind of caveats as far as how big an index will be given your parameters, or even like, calculations if you can do it, so you can predict how big the indexes will be and make the necessary changes.
Yeah, I think that's a great question, a great request. And we talked about this as recently as Monday in our search leads triage meeting. Like, it's like we get one document and we know how many documents are in the collection. Let's multiply what the size of that document will be in the search index times the number of documents, and that's one way to infer how big a search index is. It's not a perfect calculation, but that's a good start. It's better than zero, because I agree with you. We'd like to show users how big will this be, how will this operation change my resource availability in the cluster.